Good morning, ladies and gentlemen. So what we're going to be working on today is going to be putting some of these concepts we've learned in order. So the atomic size, ionic sizes, MCIs, the most common ion, those are charged particles. But what we're going to do, let's start off with just a review. What I'd like to do is I really want to finish this video. I'm going to try and talk slowly, but I'm going to try to keep moving as we go. So let's just take a look at this first question. So the first question says, which atom is bigger, fluorine or fluorine's MCI? Now remember, the MCI is the most common ion, and an ion is a charged particle. A charge would be like a plus or minus, like Na plus, O2 minus. Those would be examples of a charge. Now these ions, these elements, they have standard charges. For example, I put up the valence here for you. So the outer electrons up here, that's the number of outer electrons the atoms have going straight to the rows. But also, we've talked about it before in class. We're going to talk about the ionic charge, the MCI. So hydrogen is always going to be a +1. Lithium will always be a +1. Sodium will always be a +1. Beryllium, a +2. Magnesium, a +2. Boron, aluminum, gallium are always going to be +3s as a most common ion. Fluorine, chlorine, bromine is a -1. Oxygen, sulfur, -2, -3. There are no common MCIs for carbon, for this column here, and for the noble gases. So let's get started. We're 2 minutes in. All right, so which atom is bigger? Well, we can cheat and look over here and say, well, fluorine, its MCI is going to be -1. So right away I can say, oh, fluorine is going to be an F- charge. This is cheating. This is great. I want you to do that. But I'm going to take you through the process as well. So which atom is bigger? So let's just take a look. So we're going to draw fluorine. I'm going to pause the video and draw these out for you. So this is fluorine right here. And then this is going to be fluorine's MCI, and we're going to take a look at what that is. So let's just start off here with this fluorine. This fluorine, ladies and gentlemen, has how many shells? All right, so this fluorine, let's take a look at our shells. This fluorine has 2 shells. How many protons does it have? Fluorine, ladies and gentlemen, has 9 protons, right? So the protons equals 9, all right? And then we have how many electrons? So right here we have electrons, and the number of electrons is also going to be 9. So we have 2 shells, 9 protons, and 9 electrons. So let's take a look. This is what fluorine is. And now let's take a look at fluorine's MCI, its most common ion. Well, remember, the outside area of the atom always wants to have 8 valence electrons. And right now, this fluorine has 7 valence electrons. 9 total, but 7 valence. Now, fluorine, remember, can either get rid of 7 electrons or gain 1. And what do you think that fluorine's going to want to do? That's right, fluorine's going to want to gain that 1 more electron. Now, fluorine has 8 electrons on its outer shell. And in this case, fluorine is going to be pretty stoked. So how many shells does fluorine have? Fluorine still has 2 shells. Fluorine has 9 protons, because fluorine always has 9 protons. And then fluorine now has 10 electrons. Now, if we take a look at this, we say, well, we talked about the inside of the atoms being like a magnet. So which one of these do you think is going to be able to pull the electrons in closer? This is the way I always think. You think however you want. So we have 9 protons. Remember, the protons are in the nucleus or the center, pulling on 9 electrons. And we also have 9 protons pulling on 10 electrons. So we have 9 protons pulling in, and those protons are pulling in on 10 electrons. But then we have 9 electrons getting pulled in by 9 protons. Which will be able to pull them in closer? 9 versus 10 or 9 versus 9? And hopefully you all said, yes, it's fluorine, okay? This one's going to be able to pull them in closer because it's a better ratio, 9 versus 9 versus 9 versus 10. So if this atom is smaller, then which atom is going to be bigger? The bigger atom is going to be fluorine. And now there's lots of electrons out here. Remember, these are negatively charged. And those negatively charged electrons, they're going to be pulling against each other. There's lots of resistance, and it's going to be harder to pull those 10 electrons in. Okay, so let's take a look at the next one. So let's take a quick look. It says, what's bigger, sodium or sodium's MCI? Well, sodium, if we have sodium sitting right here, I didn't draw that out, I didn't feel like it. Sodium, ladies and gentlemen, has how many valence electrons? Well, sodium is sitting here with 11 valence electrons. It's got one shell, and it's got two shells. And then it's got the third shell. I'm going to draw the same one over on the other side. So on this next example, so I have sodium. Sodium is right here. This is going to be sodium. Okay, sodium, ladies and gentlemen, has 11 protons, which means it has 11 electrons. Now, we have to look and say, is sodium, as a general rule, is sodium kind of a happy guy? Is sodium stable? Well, no, because in sodium's outer shell, there's only one valence electron. So sodium has a couple of options. Sodium can either gain or lose electrons. So that's what we're going to do to find out the sodium MCI. So let's fill this out. How many shells does sodium have? 1, 2, 3. You can see it's on the third shell. So sodium has 3 shells. Let's get rid of that. Let's shrink it down a little bit. All right, sodium has 3 shells. How many protons does sodium have? Sodium has 11 protons. And the electrons, sodium has 11 electrons because it's a neutral atom. Let's look at sodium plus. Well, we know sodium is going to be a +1 charge. So what's going to happen? Does sodium want to gain, right, 7 more electrons? Or does sodium just want to lose this 1 electron? Hopefully all of you said, oh, sodium just wants to lose this 1 electron. And when sodium does lose that 1 electron, you can take a look and say, whoa, we got to fill this thing out. Let me change the color just so it's a little different here. What the heck? So how many shells does Na plus have? Well, if it loses that 1 electron, now there's only 2. Well, now the answer is obvious about who's going to be bigger and smaller. So something that's on a second shell is going to be much, much smaller than something that's on what? A third shell. That's right. So Na plus is going to be much smaller because there's only 2 shells, which means regular sodium is going to be bigger. That's how my brain works, where I always think about the smaller ones, and then I answer the question. So 2 shells is going to be smaller than 3 shells every day of the week. Now let's take a quick gander at which atom is more electronegative. Remember, electronegative means how well an atom can pull on electrons. So you have all these protons in here. You have protons in the middle, and then you have electrons flying around the outside. And electronegativity is how well those electrons can get pulled in by the protons. The more protons that you have, the easier it's going to be to pull in those electrons. The less protons means the magnet's not as strong, not as many electrons get pulled in. So when we're talking about electronegativity, remember there was a trend on electronegativity. As you moved across, you increase the electronegativity, which means the atoms are better at pulling in electrons. And as you go down the periodic table, the atoms are getting really big, and there's less electronegativity. Less electronegativity with the larger atoms. So as you move across, you're getting smaller, increasing electronegativity. As you get bigger, less electronegativity. So when we ask about electronegativity, what you can do is you just have to take a look at the size. So we have potassium and we have calcium. So what is going to happen? So let's just take a look. We just have to look at size. So what's the size going to be? Let's just say you have potassium here. Potassium has 19 protons. Calcium has 20 protons. So let's just do the same thing. So how many shells? That's the first thing we're going to look at. How many protons? How many electrons? So Here we go. So how many shells does potassium have? Well, both of them have 4 shells. So in that case, they're even. We can't tell which one's bigger. How many protons? Potassium has 19 protons. Calcium has 20 protons. Well, there's a difference here, which means we don't even have to look at the electrons. There's more, well, we'll look at the electrons as well, but there's more protons, which means these protons can pull in better, which means calcium will be smaller. And if calcium is smaller, that means calcium is going to be more electronegative. So the smaller the atom, the more electronegative it is. So in this case, we're going to have calcium because you increase the electronegativity as you go across, and that correlates directly with the size. And that'll be the end of our review for today. So this next section is relatively straightforward. All you have to do is know how to read the periodic table, and you have 2 different things to follow. The size of atoms gets smaller as you move across from left to right, and that's because of the number of protons. And you get larger as you move down, and that's because of the number of shells. Electronegativity increases, or there's more electronegative as you move across, because atoms are getting smaller. It's easier to hold on to those electrons. And as you go down, the atoms are bigger. It's harder for them to hold on to the electrons. But what we're going to do, I'm going to take a look, and we're going to put these in order. Now, it should be very straightforward. So let's find these. Here's silver. So we have silver, and let me do that for you so you don't waste your time. So this says put them in order from least to most electronegative, which means that if you're going to be working here, you're going to put the smallest ones over here and the biggest ones over here in terms of electronegative, okay, which directly correlates to size. So less electronegative, more electronegative. I should put more on that one, not bigger. Sorry, speaking. All right, so this will be more electronegative. And these are the elements we're working with: osmium, iridium, plutonium, platinum, gold, mercury, and silver. All right, so we have, let's just take a look. Well, which ones will be the smallest? Well, the one that'll be the smallest will be what? Most electronegative. The ones that are the largest are least electronegative. So you can see that as you go this way, it's more, that way is less. So as we go this way, it's less. So the atoms that are furthest this way are going to be least electronegative. The ones closest to the top in this upper right-hand corner will be more electronegative. So which atom is furthest to the top? Silver. That means silver right away is going to be the most electronegative. Okay, most electronegative. And this will be the least electronegative. Okay, least electronegative. So there's silver. So we've got rid of silver. Now, which one is going to have the least amount, or which one will be the largest atom? The largest atom is going to be osmium because it's furthest to the left. And if we follow, the more electronegative ones are over here. So osmium is going to be the least electronegative, right? And then what would come next? Well, then iridium would be the next. And then we'd have platinum would be the next. I said plutonium earlier. I don't think I did, but then next would be gold. And then mercury. And then silver. So it's just going to go in that order. This is the least, all the way going to more or greater electronegative and greater electronegativity as you go up. Okay, so that's how you do that one. Very straightforward. Let's take a look at the next one. Let's do an example. The next one here, we have to take a look. We're working with potassium, calcium, iron, sulfur, and oxygen. So let's just take a look at what we have. So we're looking to go from least electronegative to most electronegative. Remember, as we move across to the right, we get more electronegative. As we move down, we get less electronegative. So if this is the highest over here, then the ones on the far left would be the least. So which one's the furthest left? You can take a look. That would be potassium. Potassium would be the least electronegative. And then as we move across, the atoms are getting smaller. which means you're getting more. So the next one will be calcium. And then as we move across, these are more electronegative. We're going to have iron. And then you can take a look and you're like, well, which one is more electronegative or less? Oxygen or sulfur? Oxygen is going to be the most electronegative because it's closest to the top and it's closest to the top. That's why. So the next one will be sulfur and then oxygen. And that would be from least to greatest electronegativity. The next one we're going to say is which atom is bigger? It says write the ion symbol and explain why in one complete sentence. And that's important because when you were doing your homework, a lot of you missed that complete sentence. Well, not a lot, but some of you were just putting a simple little thing like, oh, because it's bigger. And it's like, no, you got to be a little bit more precise than that. All the answers are going to be like one of four things. So let's take a look at it. All right, so let's take a look. Now we want to know which one is bigger here, ladies and gentlemen. So let's draw out. We could either do the Lewis dot structures, or we could do the shell model. So let's draw the shell model out. So you can see sodium. Sodium's on the third shell. All right. So for this one, we're going to have Na. There's going to be shell 1. Yes, that should be blue. I'm not doing it. Shell 2, I will. Now, when we take a look and see which atom is bigger, first thing we want to do is we want to say, well, finding out if something's bigger or smaller is going to have to do entirely with one of three things. It's going to have to do with the shells, with the protons, and with the electrons. So how many shells does sodium have? Well, sodium has 3 shells, 11 protons, and 11 electrons. And that's all we have to work with. So now let's take a look at our MCI. First thing we have to do is figure out, does sodium want to gain or lose electrons? Sodium has 1 electron on the outside, so hopefully all of you are saying that sodium is going to want to lose that 1 electron. Sodium will lose that 1 electron, and in doing so, right, losing that 1 electron, all of a sudden, sodium is going to have 2 shells. So the number of shells for sodium is going to be 2, right? And right away, we know which one's bigger because this one has 3 shells, that has 2 shells. The number of protons is 11, and the number of electrons is 10. So not only is sodium going to be on a smaller shell, but sodium also is going to have a less shell, but sodium also has less electrons, which means the protons are going to be able to pull those in. So this sodium ion, this Na+, is going to get a double whammy. This one's going to be very small. But the question says which is bigger? So this sodium is larger. So what would be our one sentence? We'd be able to say sodium is bigger because there are 3 shells and Na+ has 2 shells. Okay? That would be our sentence. It has a noun, a verb, and it explains things. Sodium is bigger because there are 3 shells, and sodium plus just has 2 shells. It's a great explanation. Let's take a look at the next one. So for this next one, I've already drawn the shells for you. You can see that fluorine has 2 shells. Fluorine has 9 protons and 9 electrons. So is fluorine a happy camper? Is fluorine right here? Not really, because fluorine has 9 electrons, and it really wants to have 10. It wants to have a full shell. 1, 2, 3, 4, 5, 6, 7, 8. So this fluorine right here, which we're going to leave alone because we're comparing fluorine with the charged one. How many shells? There are 2 shells. How many protons? 9. How many electrons? 9. So let's take a look at this one here. Fluorine, this one, not a happy camper. It's going to end up being F- because this fluorine is going to want to pick up 1 more electron, which means when we come back and we write this up, the number of shells, it's going to be 2 shells, but there's going to be 9 protons. You guys see how I'm going 9 protons, and there's going to be 10 electrons. Now, you have 9 protons pulling on 9 electrons, and 9 protons pulling on 10 electrons now. So what do you think will be able to pull the electrons closer? 9 versus 9 or 9 versus 10? I think the 9 versus 9, hopefully you're all saying that that one will pull the electrons in closer. So This atom will be smaller, which means this atom is going to be bigger. And the question asks, which is bigger? So in this case, this one here is going to be bigger. And why is this one bigger? Well, F minus is bigger because there is a larger number of electrons on the outside and harder to pull the electrons in as tightly. Okay, that would be a perfect explanation. Obviously, you would write it a little bit neater. And if you're like, Pepig, what did you write? Rewind the video a little bit and I'll explain it again. So, cool, kids. That would be how that one works. I think we're just about wrapping it up right now. You know what, kids? I am going to wrap it up right there. I could do this last example for you, phosphorus, which is right here. But I'm not going to because I don't want to keep you any longer. I'm going to let you finish this video and then do your handout, which I tried to make very short for you today so that you can really focus on those few questions. If you do finish this work, please go and make up any work that you haven't done. So find a video and you're like, oh, I haven't watched that other video yet. Maybe that's why I don't understand. Or I want my grade to go up. Trust me, you want to pass my class, just do all these videos and get your work done. And it's just going to make your life so much easier when February comes, January comes. So guys, good luck. I'm sitting right here if you need my assistance.